what lessons have we learned? And obviously we've concentrated on the stuff that we see very, very often. Okay. Quite often people just have not understood what the word capacity constraint is, and they are talking about a big reoccurring problem or a thing that they spend all their working days talking about, right? A frequent problem, a persistent problem, a headache, or whatever. And they end up talking about a constraint, but it's not a constraint. Okay? If you have a certain number of problems, that's a subject to be resolved, of course, but it is not a capacity constraint. Okay? The other one, maybe it could even be the first one, is this obsession that everybody has that they have wandering bottlenecks, punctual bottlenecks, that their bottlenecks move around all the time, okay? And this we hear so often, okay? But what is that? That is nearly always self-inflicted waves of work due to management practices, large batches, the way they manage their organization, right? Which leads to waves of work going through the factory at all times, right? And so sometimes it's there, sometimes it's there, sometimes it's over there. Okay. What the truth is behind that, frankly, is that these waves are hiding the structural bottleneck. The structural bottleneck is there, right? And these waves of work are distracting you from seeing it, right? And in that bunch of resources with loads going up and down, there is one where it never gets to zero, right? It never catches up because it's the constraint of the system, right? So I put it on purpose, bluntly, there are no wandering bottlenecks. It's a myth. Maybe I'll accept that there's between 1 and 0.1% of cases in the world where there are truly wandering bottlenecks. I won't go into that. I'd prefer just to say, forget it. There are no wandering bottlenecks. You're making it up, or you're making them wander. You're creating the waves of work. Forget that. That is not what the theory of constraints is about. We're looking for the underlying structural bottleneck that is there. Okay. People say their big beautiful machine is the bottleneck, and that I find an interesting confusion. Because, as I'll come back to at the end of this presentation, that is probably the best bottleneck, or where the bottleneck should be, that big, expensive machine, right? But it's not where it is. So it's wishful thinking. That's where it should be. It's not where it is. Okay. So, frankly, if somebody says, this is the bottleneck, and they point to their most expensive and beautiful machine, I don't believe it. Full stop. That's where it should be. But we're not there yet. Okay. Beware of asking the computer, please. You've killed the data in your computer on purpose, all of you collectively. You do it every year, doing the budgets. If going through the budget process there was a resource that lit up as a bottleneck, you would deal with it in your budget process, right? So by definition, you've tortured all your data so that you can't, your ERPs don't see bottlenecks anymore, because it's a management mistake to have a bottleneck, right? So I just don't bother looking at what the computer thinks about, loading on this resource and that resource. The data is so polluted, tortured, it's not worth the time. Okay. The kicker, I didn't know how to put it. I felt I should put just one big slide saying, watch out for your quality control. It says, the kicker of this slide says, in the last 5 or 10 years, this is our data from all our implementations, 50%, half of them, had quality control as the real bottleneck. Half of them. In aeroplanes, in food, in pharmaceuticals, in cars, and so forth. And in fact, I can explain quite simply why that is. People hesitate to invest in quality control, right? It's not a value-added operation. It's not in operations, it's in quality. And you haven't realized how much extra quality control the new world requires, right? For very good reasons. We're asking for more and more checks, more and more controls and stuff to make sure that the products are safer and so forth. So the workload has increased in quality control significantly, and you've let it become the bottleneck. In one case out of 2, half the implementations of theory of constraints, whether it's in projects or in production, we're finding that quality control or quality assurance, let's say the quality function, is a capacity bottleneck, right? So think, please, check in your company, look for the cues in that part of your process, because I think you will be surprised. A specific point about assembly operations. If there is an assembly operation in a manufacturing organization, quite often people claim that this is a bottleneck. Okay, why? Because if you look indeed at the queues of work, the queues of components waiting to be assembled, you're going to have large queues, right? For me, this is an error of reasoning between cause and effect, and if you stop and have a look at these assembly lines, right, you'll see quite often that they're not working, or not working 100% of the time, because they've got shortages. They're waiting for components, or waiting for validation of documents and stuff. Okay, or in engineering to order, make to order environment, there's non-quality problems, there's engineering spec problems, and all that sort of stuff. And so often when I look at an assembly operation, there are not many people screwing things up and actually assembling, right? They're discussing problem solving and all this sort of thing, right? So what I'm saying is that you're confusing cause and effect. Things are stuck at assembly, but it is not the capacity of assembly that is the problem. It is the various things that prevent assembly happening. Okay, and that last point on the slide is simply, I don't know why, I guess I'll repeat it until I die, full kit, don't cheat with that rule. It's not theory of constraints or lean, it came from a long way back. Don't try and start assembly operations with the full kit of components, right? Not one bolt. Capacity constraints in projects. Well, it's both the same and different. And of course, when we're talking about capacity constraints in projects, we're talking about project portfolios, not individual projects, not a single project on its own, but the portfolio. All those projects go through resources. There's a capacity constraint in that. Okay. One of the big differences between a project environment and a production environment is there's even less accurate data in projects than there is in manufacturing. In manufacturing, you will have time per parts and so forth for production. How long is it going to take you to do that drawing? How long is it going to take you to find that supplier? How long is it going to take you to prove that concept? Nobody knows, so you're guessing all sorts of stuff all over the place in terms of durations, workloads and stuff. Okay, one of our clients who has a sophisticated, very powerful project management system with capacity management was showing us the state of things. They'd had it for 8 years, big organization, reputable. And we looked at the loading on the resources, and we saw they were all at 350% average throughout the organization, right? 350% workload. And I said, well, I mean, they're all overloaded. And said, yeah, I know, but we know the data is wrong. We only look at resources that have a 700% workload, right? Those are the ones that worry us. 350 is normal. Okay. So what kind of constraints do we find? Excuse me if this is rather easy to say for a consultant, but this is what we're seeing most of the time. The world changes, technologies change and so forth, right? And we're bringing more and more electronics and software into everything, even a toothbrush or whatever, right? And as you do this, I mean, designing today's cars is rather different than what it was 20 years ago, right? It's less to do with engines and more to do with the control systems. You're trying to develop tomorrow's products with yesterday's capabilities, right? And so when you're going to find capacity constraints is probably in all the new areas that you're meant to be mastering, therefore electronic software development and all that sort of stuff, right? I would add that what is kind of strange is that the testing can also be bottlenecks in organizations developing products. So it's not a good place to be. In a project environment, how would you identify the bottleneck? You can look at the size of queues, and that's usually enough. If that hasn't worked, if you're not sure because you can't see any particularly obvious capacity bottleneck doing that, well, you can still implement critical chain project management, for instance, and then you look, as we saw in the medical example earlier on. You look at, in fact, buffer penetration, things that are getting regularly late. You do a Pareto analysis of the causes, and you find that a department typically is the one that is generating the most delays. Why? Because it's overloaded. Okay, watch out for your data and your calculations, and try and keep things as visual as possible. Is this a joke? I don't know. It's also fairly true. The bottleneck is often in the middle. The company logo that I designed a long time ago, 25 years ago, has stood the test of time. There are 5 resources and it's the middle one. And it's true that you rarely find bottlenecks in the first operation, because if the first operation was the bottleneck, all the other resources in the company would have a lot of trouble looking busy when the boss walked by, yeah, because they wouldn't be getting enough work. So that's why you don't have it at the beginning, and you don't have it at the end, because since you're managing flow and lead times and your promises so badly, you have to be able to panic at the end to assemble it, pack it, and send it off on the truck quickly. So it's very rare that in assembly, I've mentioned it, but even in packaging, we find capacity constraints. Indeed, packaging so that you can do your end of month rush, we usually find it's about 4 times the capacity required. Okay. 2 little exceptions, or little regrettable exceptions. I mentioned it, I've said it, I'm saying it again on purpose: quality control, quality control, quality control, which can often be towards the end. And in software development, strangely, again I could explain it, it's in testing, probably because it's not as interesting as the other work, so they have trouble getting that right. But it's not a good place to have a capacity constraint. Right?